Hello, my name is Sebastian. In this video, I'll present you our paper, Grab the Frog, Comparing Intuitive Use and User Experience of a Smartphone-Only, AR-Only and Tangible AR Learning Environment. Besides me, Anne Elsesser, Silke Grafe and Mark Latoschik have also collaborated. Augmented reality three-dimensionally integrates virtual elements into the real world that are interactive in real time. In a learning context, AR can evoke a higher learning motivation, task performance, as well as allow for a direct and spatial application of the learning content. Tangible AR combines physical objects belonging to the learning content with so-called fiducial markers, thus adding a physical aspect to the learning process. In a learning context, tangible AR reduces the cognitive load, increases work on the learning material, improves usability, trains mental skills, and allows for collaboration. However, how does tangible AR compare to less complex smartphone-only and AR-only learning environments? Especially when using smartphones, learners do have to operate the smartphone while manipulating the tangible objects. This can result in complex interactions. To investigate this question, we hypothesize the following. When designing for two-handed interactions, tangible AR yields a similar intuitive use to AR-only and smartphone-only applications. The provision of tangible objects results in a higher user experience in comparison to AR-only and smartphone-only applications. We developed three versions of the learning environment Horst the Teaching Frog to test our hypothesis. Horst the Teaching Frog is a tangible AR learning environment. It targets the learning of the anatomy of vertebrates, in particular of frogs. The application provides a free and a guided dissection, a quiz to verify the learning progress, as well as an achievement system and high scores. The tangible AR version is based on a plush frog featuring a pouch at its belly. Inside the pouch, there are image targets for the individual organs. Scanning them results in 3D models of the organs being displayed. When extracting the markers, learners can inspect the organs up close and learn more about their biological functions. The AR-only version uses a 2D photo instead of the plush frog. Here, the markers cannot be extracted. Learners need to touch the displayed organ 3D models to learn about each organ individually. The smartphone-only version uses a 3D model of the frog that contains all organs. Touching an organ once again allows for a close inspection and the presentation of the respective biological information. All three versions provide the same learning contents and only differ with regard to the technology used. We compared the three versions in a user study following a within subjects design with 30 participants. We measured the intuitive use using the quasi-questionnaire. User experience was measured using the user experience questionnaire. Finally, we assessed the participants' preference. With regard to the intuitive use, we found no significant difference between the three versions. This supports our first hypothesis. Designing tangible AR applications for two-handed interactions yields a similar intuitive use to AR-only and smartphone-only applications. We found several significant differences for the user experience though. For the novelty subscale, we found significant differences between tangible AR and AR-only, tangible AR and smartphone-only, and AR-only and smartphone-only. Also, we found a significant difference for the attractiveness and stimulation subscales between tangible AR and the other two conditions. This supports our second hypothesis. Tangible AR results in a higher user experience in comparison to AR-only and smartphone-only. However, a long-term study is needed to confirm whether tangible AR indeed yields a higher user experience, as the results could also be caused by an effect of novelty. The preference ratings reflect the user experience results. Tangible AR was preferred over AR-only and smartphone-only. Thus, our contribution is the following. We validated the intuitive use and user experience of Horst the Teaching Frog. The next step is to compare the versions with regard to the learning effectiveness at local schools. We also compared the intuitive use, user experience, and preference of different user interface technologies. The takeaway message is that all three technologies can safely be used for classroom teaching. However, for remote teaching or homework, the smartphone-only or AR-only versions might be more suitable as they do not require physical objects. With that, I'd like to thank you for your attention.